Wonderful. Well, let's move to our fourth speaker so that we keep time tonight. Great pleasure for me to be introducing Tulsee Doshi, who I saw log in a little bit earlier on. She is product lead for Google's efforts in machine learning, fairness, and responsible AI, driving a deeper understanding of how we can build user experiences that are diverse, inclusive, and ethical. So anybody that's in our WhatsApp group, we've been talking a lot about Google recently. It's been on our minds. And it's a great privilege to have Tulsee here today to speak. So I'm just scanning.
Yes.
And there
Hello.
you are. How are
I'm
you?
excited. Can you give me access to be able to share my screen?
Absolutely, I can. Let me do that for you now.
Thank you. Hi, everyone. While Richard is doing that, just wanted to reintroduce myself. I'm Tulsee, and as Richard said, I lead product for Google's responsible AI efforts. Let me share my screen. Here we go. All right, can you all see that?
Yeah, we can, yeah.
Okay, awesome. Well, we'll get started then. So what I was hoping to do today is talk a little bit about the way that we've been thinking about and what we've learned from our efforts in ML fairness at Google, and then, of course, take questions. Dr. Eva Marie actually set up a lot of my talk very well in that she articulated, I think, a lot of the concerns that we see and some of the underlying systemic concerns that lead to bias in products and lead to the way that our products are designed and created. So some of what I say will, I think, sound a little repetitive, and I'll rush through that somewhat quickly, and then we can talk about some of the other aspects in terms of product development. So, as I think you've heard in many of the talks today, AI is being used around the world now for so many different use cases. And what you see here are actually screenshots from some of Google's product development efforts that actually span beyond the Gmail and the search and the YouTube to things like helping identify eye disease in individuals across the world, to thinking about climate change and forestry, to thinking about the way that traffic works around the world. And so in each of these use cases, we're talking about quality of life impacts that can be huge and represent multi-millions of people, multi-millions of dollars, and experiences that are very deeply rooted in the way that we live our lives. And of course, in Google, AI runs through the foundations of all of our products, whether that be the way that you send emails in Gmail, whether that be search or YouTube or our ad systems or Google Photos. And so for us, it's really critical that we think about and understand what is the impact of the machine learning systems that we're building. So a couple of years ago, Google released the AI principles, and these are 7 principles of what we believe that the AI we're building should encompass, and then also the applications we won't pursue, right? So we see here, for example, AI built should be socially beneficial, should avoid creating or reinforcing unfair bias, be built and tested for safety, be accountable, incorporate privacy, uphold really high standards of scientific excellence, be made available for a broad set of use cases, but also really specifically not allow ourselves to build AI that we think is likely to cause overall harm or could be used and is supposed to be used for direct injury, for surveillance, especially that violates international norms, and anything that we feel like goes against international law and human rights. And I think it's important that we develop these principles because while they are broad, they ground the development of what we do, and they allow us to have conversations about how the projects that we're building and the efforts that we're doing work within these principles. But as I think you heard in the last talk, humans have a history of making product design decisions that are not always in line with the needs of everyone. And this is, when I build a product, when I design a product, I often think about my own lived experiences and my understandings of right and wrong and my value systems. And that is probably true for all of us who are building our products. And so when we think about what does it mean to build a fair, a representative, and equitable product, I think we often forget that we ourselves are coming from places of conscious and unconscious bias. And so the decisions that we make, even met with objective ideas, can still lead to that type of construct. And this has been true in technology development for many, many years, right? This is a stat from the US DMV, but female drivers were about 47% more likely to be severely injured in an auto accident until 2011, when authorities actually mandated that there be female crash test dummies tested with seatbelts, not just male crash test dummies, right? And so if we think about that particular use case, I don't necessarily believe that there was malintent for car designers when they said, hey, we're going to use male crash test dummies to test our seatbelts. But When you think about what that then was impacting in terms of female drivers or female riders in cars, the impact can be significant and hugely life-threatening. Another example from the 1950s, what you see here is an image of a woman named Shirley. And this image was used in the 1950s by Kodak to color calibrate the film that they were using to identify what they should be setting their colors to. So of course, this is great, but when you look at the image of Shirley and what color calibration could lead, that may not necessarily have led to good color calibration across other skin tones. And in fact, that was the case. And it wasn't until the 1990s when chocolatiers and wood manufacturers started complaining that the colors weren't looking right in the photographs that they were taking, that Kodak realized that it had to actually broaden the calibration spectrum and what it was actually looking to test when it was testing whether the color of its photographs was working as intended. And so starting in the 1990s, you see a more diverse set of cards for color calibration to make sure that we were actually calibrating a broad set of skin tones. And so for any of these technologies, why do these things happen, right? Why do we see these things happen in the Kodak example or the seatbelt example or in our products at Google? It's because humans are at the center of machine learning development. And so throughout the seemingly innocuous design decisions we make, such as, oh, I'm going to use this crash test dummy, or this card is probably an easy MVP, we make decisions that can lead to downstream effects, right? In terms of how we sample those data sets, what are we thinking about when we develop a product? What does that look like? And the reality is when we talk about AI, if we really truly want successful AI, we need responsible AI. We need machine learning systems that are fair, that are thoughtful, that are inclusive. And we need to hold ourselves accountable to making that, right? I see a number of notes in the comments about don't be evil. And I think it's really about not just don't be evil, but also be actively intentional. Be actively intentional about what we're building so that we can build products that are inclusive. We also, I think I really love this quote from Sundar on the Google side, which is that principles that remain on paper are meaningless, right? It's not just about we should have a set of principles and woohoo, that's great. It's about how we apply those principles and what we do every day to make those principles work. So our goal and the goal of my team is to really try to figure out how we build that in practice, right? How do we build the knowledge base? How do we develop the research, the best practices, the resources? How do we actually embed that into our products in terms of proactive end-to-end improvements? And then how do we share our learnings and have that dialogue externally so that we can have these conversations? When we think about what that actually means then in practice, I wanted to walk through an example and kind of talk through how we think about it. Here you see an example from a classifier that is built by Jigsaw, which is one of the teams within Google that is thinking about hate and harassment online. And this classifier, the goal of it is to look at comments online and classify them as hateful or harassing or innocuous on a scale of like 0 to 1. So for example, a comment like, what a sweet puppy, I want to hug her forever. That would be given a score of 0.07, right? More innocuous, a nice, friendly, happy comment. Whereas the comment, you are the worst example of a puppy I've ever seen, that's a really mean thing to say to a puppy. And so we get a score of 0.84, very toxic, very hateful. And there's hundreds of these types of classifiers across the industry that aim to identify hate, harassment, abuse, spam, and more things like this, right? And these are important because they help us identify and add guardrails to our systems. But what happens when these classifiers go wrong? Here's an example. When Jigsaw published this API externally for people to use, a user found this example, where when they typed in the sentence, I am straight, they saw the score 0.07. But when they typed in the comment, I am gay, they got the score 0.84. And when we initially launched this product in 2017, we hadn't really known to test for these use cases, and we didn't appropriately test. And while we thought the classifier was doing well overall, we clearly missed these types of awful examples that we don't want to be seeing in our products. And so we took a step back and said, how do we make sure that these systems work as intended for every user, and that we don't see these types of examples for our users when we launch? And that made us go back and revisit the entire pipeline, because as you're developing machine learning, bias can come in at any stage in this process, right? Where are you collecting the data? What does that data represent, and who does that data represent? Who is labeling the data, and what types of bias are they bringing to the situation? Are you using algorithms to label the data, or humans? And what type of difference does that make? Who are the humans that are labeling the data if it's humans? And what kinds of algorithms and how precise are those algorithms if that's what's labeling them? Then what objective did you choose? Why were we training the model? If we were optimizing for precision, what does that leave? If we were optimizing for recall, what does that leave? Then you have user data that is ranked or filtered or aggregated. And how does that impact the experience? And then our users see an effect, right? And they might interact with the system in a certain way. And what does that lead in terms of the way that we continue to collect data and the way that we continue to change the system? So because bias can enter in so many different ways, and also more broadly, because ML uses and use cases and users are so diverse, I think the way that we see ML fairness can take so many different forms, right? On one hand, there are examples where we really can see the technical differences in the way that a system performs. So here you see an example from Gender Shades, which is an amazing piece of work done by Joy Buolamwini and others on how we actually think about gender classifiers. And what they did is they looked at a bunch of open source or open access classifiers that look at classifying an image as male or female. And they saw how well these classifiers did across different genders and different skin tones, right? And they saw, for example, here that while the system was working really well for certain communities, for darker skinned women, these classifiers were often not working well at all. So this is a case, for example, of one system working better than another. On the flip side, an example that we've seen in Google Translate is a very different type of ML fairness concern, but still a fairness concern, one of stereotyping. Here you see Turkish being translated into English, and Turkish has no gender pronouns. And so the sentences at the top pretty much translate to, this person is a nurse and this person is a doctor. But when we translate them to English, Translate automatically puts gendered pronouns on these sentences. She is a nurse, he is a doctor. Again, a fairness concern, right? Something we don't want to promote, that one gender is more likely to be a specific person or a specific profession versus another gender being another profession. But we also want to make sure that we're able to translate in a way that is accessible for users across the globe. So for each of these problems, the solution space looks very different, right? For the case of gender shades, a lot of the APIs in question really focused on data augmentation. How can they make sure to get more images from darker skinned women to make sure that their classifiers do actually work better for this population instead of making problematic errors? In Translate, we took a very different approach. We said, wait a second, even if we had a perfect system, we may get this wrong. We may assume that something is male when it shouldn't be. We may assume that someone is female when they shouldn't be. And what about non-gender binary individuals or individuals who don't prescribe to a particular pronoun? So instead of really coming up with a translation our own, we said, hey, this actually could be a product design question. In addition to making the classifiers better, we would also want to allow users to pick and choose and provide the right context. So in this example, you see the word friend being translated into Spanish. But here we provide users with both options, both the masculine translation and the feminine translation, so that users can actually decide, am I aiming for a masculine translation or a feminine one, and how does that affect my sentence? And I think this is still a work in progress, and there's still a lot more we need to do on both these fronts. But I'm hoping these examples illustrate just how diverse the problems can be and also how diverse the solutions can be, and that there is not necessarily a one-size-fits-all problem to fairness. It's not necessarily that you can say, oh, we have a fairness problem, great, I'm going to throw this solution at it and we're done. I think it requires a lot more critical inspection into what we're doing and how we might want to go about it. And that really brings me to the kind of core point that I wanted to make today, which is that fairness in product development is very much contextual, right? It very much depends on who are the decision makers in the room, who are the user groups, what data sets did we collect, what metrics did we choose to evaluate on, and where did we and how did we allow humans to be involved in that decision, so that we weren't just relying on the algorithm itself, but giving users control and context in the decision that we're making. And it's therefore important that throughout the development and design process of a product, we need to make sure that these aspects are included and that we're thinking critically about what elements need to be thought about and what aspects of fairness and inclusion matter here. So then how can you actually approach fairness in model development if we're saying it's so case by case specific and so different? Well, you know, the first piece I think is establishing the problem with diverse users in mind. What would this look like for different users? How might different users experience a particular search result or a translation request? How do we then collect data that represents that broad set of users? So are we actually getting data that represents the broader base that we want? If our product is global, then the data that we represent should also be global. If the product is based in the United States, maybe we can focus on the US population. If the product is based on a particular city or a town, how do we build that out? We can then define fairness opportunities where we think that there are opportunities to really make the product more inclusive. Where does it look like for the product to truly be inclusive? What are the things that could cause harm, right? And where are the potential failure modes of the product? And based on that, can we define metrics to capture each of those modes, all the possible failure modes, all the possible opportunities, and then test effectively for those? And then design the right mitigation approaches and the right monitoring, making sure that the system really works holistically. And of course, underlying all of this is developing and growing an inclusive workforce and making sure that you're bringing in diverse perspectives so that when we are establishing these problems and collecting data and defining opportunities, we're doing that with a diverse set of perspectives. And that's not just about demographics. It's also about expertise, making sure that you don't just have technical expertise in the room, but also expertise from design, sociology, anthropology, and even more. So from our perspective too, we also want to make sure that not just our design processes and our approaches, but even just when you develop ML, that we're actually thinking about how we can embed these at every stage in the process. I saw a note in the comment about how ML is not contextual. And I think it is true that ML is very governed, right? And so we can, throughout this process, think about how we actually go about building ML and what are the stages that we put in there, right? So from defining the problem to how we collect and prepare training data, to how we train the model, to how we evaluate, and to how we deploy and monitor. And at each stage, we can build a set of tools that actually help developers go through these processes. At Google, we've been developing a responsible AI toolkit where we're trying to put tools at each stage of this process. So for example, with defining the problem, creating a guidebook around what kinds of questions to ask, what kinds of users to consider. As you're collecting and preparing the data, tools that help evaluate the problem, right? And help you look at the representation of data sets. Tools that help you train the model, especially in terms of privacy preservation and thinking about fairness constraints. Tools that help you evaluate your performance to make sure that it works well across a diverse set of users. And the tools that help you monitor and deploy this over time. For example, with evaluation, we want to build up tools that allow developers to actually evaluate across a set of slices. So how do you evaluate your performance, for example, across different demographics of users so that you can make sure that the model is equally accurate, if not more accurate, for certain communities. But you want to be thoughtful and careful about where those accuracy differences are and why that's happening and what harm could cause when you have more or less accuracy for certain communities. We want to then make sure that developers can investigate. Well, why did something go wrong? How can I explain what happened and how can I find the root causes to improve it? And then how can I debug it even further so that I can explain those predictions over time? One thing I'll also call out is the importance, I said earlier, of intentionality and how that can translate even just through transparency. Because so much of our decision making goes into the way that we build technology, and because so much of that human bias translates through, I think a lot of what we can do is really document our choices and decisions and really go back to that notion of contextualization to say, what did we choose to do when we were developing this product, and what kind of implications and impacts could that have? So one call to action I'll say for this whole group is, I think one thing we really try to push towards is being more conscious about documenting our choices. This here is a screenshot of one of our first model cards. And this idea is that you should be able to develop a card that transparently reports the choices that you've made. So for example, for Google Cloud's face detection classifier, can we be thoughtful about what are the limitations? When does this classifier work and when doesn't it? What were some of the trade-offs that were made during development? How does it perform across different communities and groups? Allowing users to actually test and provide feedback, but giving a holistic place where we can actually say, what is this model meant to do and what does it do? And can we see and understand those choices that were made? Google's first model card also contains, as I noted, these types of dimensions of, for example, how does the model perform across different age groups? And so here you see the breakdown across senior, age, adult, and young. And you can see, what the recall looks like across these different communities. So you can make a judgment call for, does it actually work for your user base? And does it actually reflect the needs and the desires you have for your product? You can also do this for data sets, documenting who collected the data. What are the characteristics of the data? What is it meant to be used for? And what was actively excluded? What does the data set represent? Here, for example, we collected a data set that was meant to represent a broader global population. We said, hey, we don't want a Western specific data set. We want to collect a data set of images that represents the globe. But when you look at the geographic distribution of the data, you see that the data is actually 83% from India and only 2% from other regions. And so while this does represent a non-Western perspective, it also is very indexed on a different particular cultural context. And that's really helpful for someone who might be picking up this data set and wanting to use it. We are working on trying to figure out how to make these processes less intensive, how to make it easier to create these types of model cards and data cards. And if this is something you're interested in, I would definitely recommend you check out our model card toolkit. We've released it in open source, and we're looking for feedback for how we can make it better and more useful for developers, as well as business stakeholders and others who may want to know kind of what are the details of a model and how do we build that out over time. I'll stop there. I know we're running low on time, so I kind of tried to speed through as much as I could, but I'd love to take questions or have more of a discussion there as well.
Thanks, Tulsee, so much for your talk. And it is so important to know that, fairness and responsible AI is so much important. And bias can come in at any step of the development process. People forget that. People have a thought later when the product is designed, what they have missed out on. And there could be biasness also because of no diversity when the data set is taken into picture, I think. So I think having an implementation at every step in the development process will improve our models, and having a successful AI definitely needs responsible AI. I must say that. So beautiful talk, and I think we'll switch on over to the questions. I'll just pose one or two questions, and then there are some questions for Eva as well. So Tulsee, people have to ask, do you think some societies are more ready than others to act as hotbeds for developing fairer ML products? For example, Nordic societies that often embrace diversity versus a society whose socioeconomic setup has not yet embraced inclusivity.
It's a good question, and I do think society matters, right? I don't know that I can comment explicitly on whether there's a particular society that is more well set up to do this, because I think that every society has its own biases, right? Some may have better handled certain biases and be more inclusive in certain aspects, but maybe not inclusive in others. And so I think it's actually really important for us at every society level to articulate where are the biases, where are systemic issues and systemic discrimination at play, and how do we make sure that that is part of the conversation when we're developing these systems? Because I think that's the only way that you're going to get to fairer systems, is by really forcing that conversation at every society level.
Definitely agree with you. And I think we have one more question that I would like to ask you. Model cards are great progress for companies. Disclose where and how they got the data that they use to fuel their AI systems decisions to evolve for explainable AI. But what happens when there's proprietary or legal issues that prevents a company from disclosing black box?
Yeah, it's a great question, and I think this is one that we've been thinking about a lot with model cards as well. And I think there's a line between what is proprietary information and what is, sort of open transparency about the goals, right? So for example, if I'm developing a model, I can probably be transparent about here's what I'm developing the model for, here's what its use cases are meant to be, here's how we expect people to use it, here's how we don't expect people to use it, here's how the model performs. I can say those things without giving away proprietary information about how I've developed the model, or what maybe I did in terms of fancy machine learning approaches. And I think there's going to be more and more of a discussion as regulation happens about where those lines should be drawn and what information should we be required to ask technology companies for, and what information should we not. And I think that's actually why it's so important that we think about regulation and have regulation, so there is more consistency in where companies draw that line.
Thanks so much, Tulsee. There's one more that I'll go for you. Andrew has a question. Can these points be built into MLOps pipelines? More and more, these are tracking things like hyperparameter choices for models.
Yeah, I actually think that is going to be, I'm pretty excited about that direction, right? I think you're seeing a huge influx of MLOps companies, right? A huge growth in companies who are thinking about how to build machine learning and how to validate machine learning, how to track model development and register model growth. And I think honestly, the more we can build in these considerations into that process, I think the more effective it's going to be, because we're going to just literally build into what developers are already doing and help them kind of make these decisions. I do think a lot of these decisions are outside the model ops process, right? So things like what choice did you make when you were collecting the data? That often doesn't get necessarily recorded at the MLOps part. Usually you've already ingested data at that point and are now reviewing it and tracking it. And so I think there's pieces that we need to embed at the MLOps stage, but also pieces we need to embed at a higher level as well.